looking at lesson 45? Introduction to coordinate proofs. I can't go any further than this. Well, I was getting it all like so that I could reach a little bit further. Yeah, I turned it on.
Don't say hi, Kayla. Yeah, she texted us and like, yeah guys, I love you guys, in case you die and like, the boat goes down. Yeah, don't die. Don't die.
Just tread water for the next 7 hours. All right, so we've got an example. They want us to put D, E, F, G on the coordinate plane. They tell us that it has a length of 5 units and a width of 3 units. So see if you can draw a coordinate plane and position your rectangle. Yeah, it's more practice problems. Okay, who wants to come show theirs on the board? Do you agree? Does yours look like that? You put yours there? Turned it? Here, 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 here. Does it really matter? As long as it's a rectangle on the coordinate plane. Does that make sense? Okay. So, what is a coordinate proof? The style of proof that uses coordinate geometry in algebra. It's probably going to be your favorite type of proof. I think it's the easiest. You're probably not even going to realize that we did a coordinate proof when we do our first example. No, I mean, they're going to be a little bit more in depth than that. That was just putting it on the coordinate plane. In a coordinate proof, a diagram is used to place on the coordinate plane. So you're going to put some picture on a coordinate plane. They can be placed anywhere, but it's usually easiest to place one side on an axis or to place one vertex at the origin. So you can place them anywhere, but if you place them on an axis or a vertex at the origin, it makes your work a little bit easier. So you don't have to do that. It'll just make your math easier to do. So there are some examples. You don't have to draw those pictures, but there are some examples. Do you see how they've got either a vertex at the origin or a side on an axis? Okay. So we're going to use a coordinate proof to show that the triangle is an isosceles triangle. Well, they give you the points. How do we show that it's an isosceles triangle? Do what? Find the distance of the sides. Okay, so what side do y'all want to start with? The left. Okay, LN. So how would we find the distance of LN? Two minus 0 squared. Okay, so you have 2 squared plus 4 squared. Four plus 16, which is 20. 2 square roots of 5. Y'all remember your distance formula? Okay, now what? Okay, let's do MN then. So MN, two minus 4 squared. So what is 2 minus 4? Okay, so negative 2 squared plus 4 squared. What is negative 2 squared? Plus 16. Square root of 20, which is 2 square roots of 5. Do we need to do the third side? Why not? Isosceles. We don't care about that third side since these two are already congruent, right? So, do what? Yeah. You could also just say, because you don't have to do distance formula, you can actually just count since it's on a straight line. So, now what? LMN. LN and MN both equal 2 square roots of 5. We're done. That's it. I told y'all were going to like these. They're not too difficult. Any questions here? Okay. Moving on to another example. A square has a side length of t. Place the square on the coordinate plane and label each vertex with an ordered pair. It's t. It's just the length of t. All right, Emily, go draw yours. She was the closest. And then I'd say Scott was the next closest. What your answer should be. Okay. But what did she not do? Label your vertices. The rest of y'all used numbers for your vertices. But do we know how long this square is? We can write the ordered pair. What is this one? What is this one? Nope. O. T. 0. Does that make sense? What is this one? No, because it wants it an actual ordered pair. And then what is the last one? That's what it actually wanted. If you had not put it at the origin, then you would have had to said, like, let's put it over here. 1, 2, 3. And then you'd have to, like, 3 minus t, and then something else. Like, it'd make it a lot more difficult. Something like that. It'd make it a lot harder. Because you don't know how long t is. Yeah, but if you put it at the origin, then you know that they're all t long. Does that make sense? Okay, let's try another one. Parallelogram with one side labeled K. Assign possible coordinates to the vertices. The rest of you did not draw a parallelogram. Y'all drew rectangles. Rectangles have 90-degree angles. Do we know it has a 90-degree angle? Destiny's isn't 100% accurate, but hers was a little bit closer. Okay. So she labeled this one as 0, 0. I can't read it. Let's see. And then she said that this side here is K. So let's erase these over here. Do those two vertices make sense? Yes. Okay. You go over however many, and you don't go up any. You always start by going left or right. So we went over some number, so K, and then we didn't go up any, so 0. How long is this slanted side? We don't know. So how far over did we go? We don't know how far over we went, right? A. Yeah, make up a letter. How far up did we go? We don't know. P. Okay. Yep, they're both just a random letter because we don't know how far over and up we went for that point. It doesn't want you to assign actual numbers. Okay, what about, because they were on the y-axis, x-axis, and at the origin. Okay, what about this one? We went over K, and then we went over another A. So A plus K, how far up did we go? P. And then since this one gave us R, S, T, and U. A plus K, and then P. You went over A plus K, and then you go up P. Because this length here is K. So this amount is A. So we went over K, and then we went over another little bit A, and then we went up P to get there. And the R, S, T, and U matter. It could be any of the vertices. You just got to put them somewhere. Does that make sense? What part of it? They're just, it's not. A plus K is some number. P is the Y part of it. You went up Y. Because it's the same as P. These two are for this point. They both went up P here and here. So that's the Y coordinate. For the X coordinate, we went over K, because that's this length here. And then this amount right here is A, which is the same amount as over here. So this is K plus a little bit more, which is A. So K plus A is that X part. Let's look at another one. Assign coordinates to the vertices of an isosceles triangle ABC with a height of 6 from the origin. And there is not just one way to draw this one. start y'all's on the little camera thing. We're going to go over whether they're right or not. Don't change yours after you see someone else's, because there's more than one way to draw it, okay? So, are y'all done drawing yours yet? Okay, go ahead and finish. All right, Scott, you want to come show yours? Again, don't start messing with yours, because yours may still be correct. All right, does this one work? Does it have a height of 6 from the origin? Where do we got to go? Did we go up 6? So is that a height of 6? That's a little bit more than 6. So would this one work? But if he took it and pushed it over here, it would work. Does that make sense? You too? Okay.
Like he put his height of 6 on the...
His height of 6 is over here. The height of 6 is wanting to come over here. So your triangle, yeah, your triangle would need to be moved over 2. Okay? All right, Sean, let's see yours. Okay, so is that part right? Okay, is this an isosceles triangle? What would he need to put for his vertices? He had negative 3, 0, and 3, 0, but do we want numbers? What do we want? Okay, so like what? Q and negative Q. That would work. Okay. Jason, come show us yours. No, don't erase yours. Okay, over here. He went up to, he says that's 0, 6, and over negative B0 and over B0. Does that work? Good. Molly? Not everybody drew that same one, okay? All right, does this one work? No, because the same one as Scott's. It's okay. Come, okay, let me see yours, Molly. All right, the height here is not going to be 6 because there's not an actual like vertex there. It's over here. So the height from the origin is going to be more than 6. This isn't 6. This is more than 6. So the height wouldn't actually be a 6. Because they had it coming up from here all the way up here. This is 6 from here to here. But the height here starts over here. This is a height of 6. What do you mean? They just thought about it. All right, Miranda. Okay. Does this one work? Okay, Jamar? It works. Yes, it does. I think it does. Okay, does this one work? Oh, let's think about it. Okay, so height, is it 6 here?
Yes.
He says this is 0, 0, and that's 0, 6. We can let that be the height. That's okay. It says just from the origin, the height has to be 6. Now, is it isosceles?
Sarah, you look so confused.
So for this point, Shamar, I would say A and then 3. You would have to say A and then 3, not B here. So that since you know that this is 6, this would have to be a 3. But yeah, that's right. Okay? Destiny? All right. Does this one work? Yeah, that's a 4, 3, 0, 0, and 0, 6. This just needs to be an A or a B or just a letter. But yeah. Okay, Sarah? Okay. We've seen this one before. It works, huh? Okay. Emily? Huh? Let me come see it. What is? Oh. Oh. Well then, I get to show you mine that no one drew. Yeah. Okay. All right, I'll show you what mine looks like. Nobody did this one.
I thought about this.
Is it isosceles?
Yeah.
And it has a height of 6, right? Yeah. Yeah. You could put it down here. Or you could do a right triangle. Yeah. Mm-hmm. Yeah. Okay. So now we want to prove that the diagonals of a square are perpendicular to one another. So how would we do that? Okay, let's draw a square. Where do we want to put our square? Somewhere at the origin. Okay. And where else? Do you want to do that square we did earlier with t's? That's going to be little bitty. I'm going to use that square that we had earlier from one of the first examples. How do we prove that the diagonals are perpendicular? The slopes, okay? What would we do to find the slope of that one? Okay, y2. So 0 minus t over t minus 0. Negative t over t, which is negative 1. How do we find the slope for the other one? T minus 0 over t minus 0, which is t over t, which is 1. So how do we know they are perpendicular? They're opposite reciprocals. Therefore, the diagonals of a square are perpendicular. That's your proof. That's all you have to do. Not too bad, huh? Okay. Looking at one more. Show that the wading pool has a surface area that is 3/10 the size of the larger pool surface area. Mm-hmm.
is the waiting part
How do we find the surface area? Okay, but we're looking at just a pool, right? How do we find the surface area of this room? Like, just the room. Well, let's say I want to find the surface area of this. What would I do? Length times width. Because they don't tell us any height, do they? So how do we find surface area? It's basically just the area. How would you find the area of a pool? Y m times n. Okay, it goes out m and then up n, right? So the pool is m n. What about for the wading pool? What is the base? It's 3/5 m. Y negative, or not, okay, don't use negative. Just use n. Why is it a negative n? Because you go down n, right? So what does that equal? So show that the wading pool has a surface area that is 3/10 the size of the larger pool. Did we? That's all your work. Are some of them just showing that little work? Yep. That's it. All right. I don't think we need to do any of these. I'm looking. Okay. It's actually not that bad. They give you the vertices for a parallelogram, which you did vertices for a parallelogram earlier. And then they want you to find the coordinates for a similar parallelogram if the similarity ratio is 3. What does it mean by the similarity ratio?
1 to 3.
This one is a third of the size of the other one, or the other one is 3 times this size. So what's 3 times 0? So that one doesn't really change. Yep, just put a 3. Just put a 3 in front of all the numbers, because they get multiplied by 3. That's it. Not really that hard, huh? Okay, so what is your homework for tonight? When is this problem set due?
Not next week, but the week after Monday.
For him. Because he's going to be out of town. I mean, not out of town, he's going to be sick.